So let's have a look at reading or interpreting some different graphs that we might come across. So we've got a column graph here. We know it's a column graph because of these columns. A bar chart would go across, but columns go up and down. So it's showing people's favourite desserts. So we've got the different desserts listed across the x-axis and the frequency or number of people who elected that dessert as their favourite up on our y-axis. So if we wanted to know how many people were surveyed in total, we would simply have to add all of the different frequencies together. So we'd be taking 15 plus 10 plus 6 plus 9, so on and so forth, and that would give us the total number of people surveyed. If I wanted to pick 3 that I wanted out of the favourite desserts, I would be going for the top 3, so the ones that had the highest frequency, because obviously if they've been selected as people's favourites, they must be quite good. So that's that graph there. Let's move on to this line graph. So we know it's a line graph because it's connected by a line through the points plotted on the graph. So it's showing the number of customers over time. That's our title. So we've got our weeks listed across our x-axis and the number of customers up our y. So what it's saying is that at 1 week we had, say, 50 customers. 2 weeks we've gone up to 200 customers. 3 weeks we're right up at probably 375, I'd say, 350, and so on and so forth. So in what week is the maximum number of customers? So we simply go across and see where our highest point is plotted. So I would say that it's up here, this one here, and that is at week 6. All right, and what time period does it cover? So we can see that it's from week 1 through to week 10. We've got week 0, but of course at week 0, we're not, that's sort of our initial value. We don't have any customers at 0 weeks. So in what week does the number of customers grow the fastest? So this comes back to this gradient or steepness of the line. So where the line is the steepest is going to be our greatest growth period in the number of customers. So you would see from here we've gone from about 50 to 200. From here we've gone from 200 to just 350. So I would say it's in that between week 1 and week 2 that we had the greatest growth, or perhaps week 2 to 3. It's a bit hard to see on my computer, unfortunately, but that's how we're going to calculate it. Which line is the steepest, which part of the line is the steepest. Okay, now let's go look at this. This is a scatter plot. So as you can see, it's just got points plotted all over it, and they're kind of scattered. You can see that we've got this really tight cluster down here at the bottom, and then we've sort of got an increased positive relationship, but they do become more spread out. So it's looking at ice cream sold versus the temperature. So this is the temperature plotted across the x-axis and the number of ice creams sold. So when the temperature is at about 5 degrees, I'm not sure if it's Celsius or Fahrenheit, you should definitely have that in labeling your graph. So at about 5 degrees, we're selling probably 10 ice creams, maybe fewer. But once we start getting up into, 40 degrees, we're selling over 160. So I would describe the pattern as being a positive relationship. So as you can see, it's got that positive sort of relationship. So the hotter the temperature, the more ice creams we sell. So if we look at this question, if somebody asked you what the average number of ice creams sold on a day in April is, what would you tell them? So from this graph, can we actually tell where April fits in? can we tell them, that information? So I would be saying that unfortunately from my scatter plot that I've got, that information isn't available to me because I don't know where April is. I could make an estimate based on the temperature, but again, that's not accurate. That's not what my graph is telling me. So I can't use this graph to supply that information. All right, so right here, this is a bar graph. And again, it's just plotting different hobbies against their frequency. Got a stem and leaf plot and a dot plot. So the dot plot, one person is represented by each dot, and you simply just place it on which they have elected. I'm not actually sure if it's their favourite breakfast. Again, you're not going to use a dot plot if you've got lots of data because you're just going to have too many dots. And then you've got your stem and leaf plot here. So remember, it does have to be ordered. So we've got our stem, which is ordered, and then our leaf, which is ordered again, and a key. So saying that 2-1 is actually equal to 21. And we can use this to find some of our summary statistics. We're actually going to go on now and have a look at a back-to-back stem and leaf plot.